Okay, today we're going to work with exponents. This is a skill that as pre-calculus students we have to master. We can't just have it partially, we have to have it all the way. And I just want to start off with a list of some properties of exponents. And as we go, we'll do simple little examples. And some of these you already know very well. But here's the first one. If I have a to the m times a to the n. Now notice my bases are the same. A to the m times a to the n. The bases are the same. If that's the case, then I just add the exponents. Okay, I'm going to add these two. So it will become a to the m plus n power. So, for example, if I had x to the third times x to the 14th, excuse me, it would be x to the 17th. All right? Now, common sense would tell you if I divide like a to the m divided by a to the n, that I would subtract those exponents, a to the m minus n. So let's say that I had x to the 14th over x to the third. That's going to be x to the 11th. You would subtract those exponents. All right? And keep moving. The third property is the power to a power. If I have a to the m, the whole thing to the n. Power to a power, you multiply. A to the m times n. So, quick example. If I had, I'll keep using these same two numbers just to make it fun. X to the third, all to the 14th. If I have a power to a power, I multiply the exponents. So 3 times 14 is 42, I believe. So this will be a to the 42nd power. Yeah, x, whatever. I was using a up there and just kind of need some more coffee this morning. Next, what if I have a times b to the m? Well, then the power gets distributed to both of our terms in here. So this would become a to the m, b to the m. Now, often with exponents, you have to combine properties. So what if I had x to the third y, the whole thing to the 7th power? Well, when you do this property, when I distribute this to this 3, I have to use this property up here. So this will become x to the 21st. You have to multiply the 3 times the 7, and then it's y to the 7th. All right? The next one seems oh so easy, but it seems like so many people forget that anything to the 0 power is 1 automatically. Don't forget that. And the last one is probably one of the ones that people just, I don't know. Some people just struggle with it. I don't know why. But it's this idea of a negative exponent. A to the negative n. What that means is that the a to the negative n gets moved to the denominator. and the exponent becomes positive. What's on top? A 1. Now, I'm going to call this part A. Part B would say, what if I had 1 over a to the negative n? Well, I could show you with, technically, I'm going to come over here to the side. This means 1 over a to the n. So then you multiply by the reciprocal, okay? So 1 times a to the n over 1. And so what you get is, in this case, this is just a to the n. So if you have a negative exponent in the denominator, it basically moves to the top. All right? In other words, they just kind of trade places. All right? If you have a negative exponent up here, it goes to the bottom but becomes positive. If you have a negative exponent down here, it goes to the top but becomes positive. All right? And so you get problems like this. I'm going to skip ahead for a second and show you just, the kind of stuff that we kind of fight. What if I had x to the negative 4th over y to the negative 7th? Something like that. Just as a quick example. Well, based on everything that I just told you, with the negative exponent, we're just going to flip these. Okay? This is going to, let me get a different color, something pretty. How about a Christmassy type color? This is going to come down here, and this is going to come up here, and they're going to become positive. So it's going to be y to the positive 7th over x to the positive 4th. Now, where people kind of get messed up is something like this. What if I had x to the positive 5th all over x to the negative 2nd? Something like that. Well, this time, the one on top is not negative, so it doesn't go anywhere. Okay? But the one on bottom is going to come to the top and become positive, which is what we just said. So this is going to become x to the 5th times, it is a multiplication problem, times x to the 2nd. Like that. Now what do I do with the 5 and the 2? Add them, and now we have x to the 7th. All right? Makes sense? But people, for whatever reason, just kind of struggle with negative exponents. So we've got some more examples to go through. Let's get right to it. If they say evaluate, then they want you to find the answer. But they want you to use properties to do it. Like this one, 4 to the 3rd times 4. Now don't forget, if there's not an exponent written, what is the exponent? 1. This is a 1. So this is the same thing as 4 to the 4th. And then you could just use your calculator from that point on to figure out what 4 to the 4th is. 4 caret 4, that's 256. Okay? But we're wanting to see this intermediate step where we use the properties. How about 8 to the 7th over 8 to the 5th? Just start with some easy ones here. What do I do with the exponents? Just subtract them. So this is going to become 8 to the 2nd, which we know. Now don't make the the 8th or 9th grade mistake. You're not in 8th or 9th grade anymore. This is not 16. People do that all the time. Oh, 8 to the second, 16. No, it's 8 times 8, which is 64. Then, okay, let's do one where you maybe have to put your thinking cap on a little bit. 2 times 3 to the negative third over 4 to the negative third times 3 to the negative 1. Boy, that looks scary. But if you remember everything I just told you about negative exponents, it doesn't need to be that painful. We just need to do some switching places. All right? So let's look what I've got here. Obviously, these two need to trade places, and this one needs to come to the top. So when I do that, I'm going to have the 4 to the third is going to be on top. The 2 did not go anywhere. And this thing comes up here, so it'll be times 3 to the first, all over. This one has to come down to the bottom and become 3, go back to blue, to the negative third. Now once you get that far, at least all those negative signs are gone, and we're starting to feel a little bit better. Oh, yeah, I'm sorry, it should be a positive. I didn't mean to put a negative. Thank you. So, what do I do now? Well, I could subtract the 1 and the 3, do 1 minus 3. However, I think in this case, and the reason why I don't want to do it that way is because I wind up with a 3 to the negative 2, and then people are like, well, where does that go? I prefer in this case, when this exponent up here is smaller than this one, and they're both positive, I prefer to think of it as this is the same thing as 3, and this is the same thing as 3 times 3 times 3, and that goes away, that goes away. And now there's no doubt of where the 3 times 3 stays. Where does the 3 times 3 stay? In the bottom, right? So now I have 4 to the third times 2 all over 3 to the second. And from there, now we're ready to use the calculator to find our final answer. All right? And I'll just leave that for you to do. You're good with calculator. Bless you. Number 4. 4 to the negative 2 to the negative 2. Well, in this case, I've got a power to a power. Don't overthink it. Power to a power, you multiply these two. This becomes 4 to the positive fourth. And then you just use a calculator to finish it. All right? Now, they're also going to give you some where you're asked to simplify. Something like this. Negative 3 AB to the fourth times 4AB to the negative third. Now, we've got several things going on here, and you just want to take one at a time. The first thing we've got going on is we've got some coefficients. Coefficients. So I have a negative, remember this is multiplication in here. So negative 3 times 4 is negative 12. Okay? Now what I've got is an A times an A, which is just A squared. Okay, that's easy. And then I have B to the fourth times B to the negative third. I'm going to add those exponents. So this will be B to the first power, or just B. All right. Let's do another one of these. 5x cubed over y all to the second power. Well, I have a power to a power, and I've also got a product and quotient and all kinds of junk going on the inside. So this is a good one for us to go over. This second power has to go to everything inside. So I'm going to have 5 to the second, x to the 6th. Power to a power, you multiply. All over y to the second. We could clean that up a little bit and make it 25 x to the 6th over y to the second. I know all of this is review. You've done this before, but it's absolutely necessary that we take a day to cover it. You're going to have some where they tell you to rewrite with positive exponents. So obviously that means there's going to be a bunch of negative exponents. Don't let that worry you. We'll start easy. X to the negative 1. Well, how do I write that with the positive exponent? 1 over x to the 1, or 1 over x. All right, that's an easy one. You knew they wouldn't stay that easy. How about 1 over 3x to the negative 2? Well, in this case, we've got a negative exponent in the denominator, but does the 3 move? The 3 does not move. All we're going to do is move this up here. So I'm going to have x squared over 3 like that. That problem's done. All right, those two are pretty easy. Let's make it a little bit more challenging. How about 12a cubed b to the negative 4th all over 4a to the negative 2b, something like that. Well, we've got a little bit of work to do, and we've also got coefficients. This part right here is pretty easy. That's just going to be 3. Where's the 3 going to go? It'll be on top. All right. So I know whatever happens, I'm going to have a 3 up here. Now, I've got these a's that I need to deal with. There are two ways to think of it. You could do the subtraction thing, 3 minus a negative 2. That's one way to tackle it. In this case, it works out kind of nice. 3 minus a negative 2, isn't that a to the 5th? That's one way you could deal with those a's. Another way is to think, okay, here's my fraction bar, and I have an a to the 3rd, and this needs to come up to the top, which makes the a to the 2nd there, and there's your 3 plus 2. Now the reason I went over that is because sometimes, these numbers are, one's bigger than another. What if this would have been a to the 3rd over a to the 7th? Well, what's 3 minus 7? 3 minus 7 is negative 4, right? Well, that doesn't give you a positive exponent. Isn't that the whole point of this? Is to get you positive exponents, right? And so that's why I say sometimes it just makes more sense to say, oh, this is a times a times a over all of these down here, and those go away, and now you've got your positive exponent in the bottom. Okay, we need to understand what's going on with exponents, not just learn rules. All right? Now, I never took care of the b. We're supposed to be getting positive exponents. So what I would do is I would move this thing down here. So that now I have b times b to the fourth. That's what I would do. And then you need to add your exponents. This is a 1, so your denominator is going to have a b to the fifth. The top is 3a to the fifth. And that's your final answer. All right, and that's probably about as complicated as you'll see. But there's several things going on there, and just be careful. If you get in a hurry on these, you'll probably make a mistake. Let's do one last problem, then we'll stop. (3x² over y all to the -2). Well, I've got a power to a power, and I've got a quotient, but remember, we're trying to get positive exponents. Well, the first thing I would do is I'd go ahead and distribute all these, just to clean it up a little bit. 3 to the -2, x to the -4, y to the -2. And once you do that, you see that to finish it up and get it with positive exponents is really not that painful, because there's just one of each. So I just need to move all of these where they need to go. These two need to come down here, and this one needs to come up here. So I'm going to have a y to the second on top, and I'm going to have a 3² x to the fourth on bottom. That 3² is just going to become a 9, so it's y² over 9x to the fourth. My pen is lagging behind there. And we will stop there for today.